Hi everyone, good morning. Welcome back to our channel. Today we are going to learn time calculation. PIC16F877A time calculation. If you have ever wondered why an LED blinks faster with one crystal and slower with another, or how functions like underscore delay underscore ms millisecond, okay, underscore ms mean millisecond, open bracket close bracket, actually works. This video will answer these questions. By the end of this lesson you will understand instruction cycle and clock frequency, time calculation for 20 MHz and 4 MHz crystals. Why are defined underscore crystal underscore frequency. Before we begin, please subscribe to our channel and press the bell icon so you never miss our latest videos. Let's get started. Why do we need time calculations? Every microcontroller performs operations according to its clock frequency. Without understanding timing, blink on LED accurately, generate delays, communicate with sensors, control motors, use your SPI or I2C correctly. That is why time calculation is one of the most important concepts in embedded programming. The PIC16F877A uses an external crystal oscillator, and the common crystal frequencies are 4 MHz, 8 MHz, 20 MHz. The crystal acts like heartbeat of the microcontroller. The higher the clock frequency, the faster the controller executes instruction. One real-time example: imagine two students solving the same exam. One writes very quickly, the other writes slowly. Both answers the same questions, but the faster student finishes earlier. Similarly, a 20 MHz peak executes instruction faster than 4 MHz peak. One instruction is not executed in one clock cycle. The system of 877A requires 4 oscillator cycles to execute one instruction. The pipeline are fetch, decode, execute and store. These pipelines are 4 instruction cycles: fetch, decode, execute and store. The instruction cycle is instruction cycle equal to 4 divided by f oscillator. This is the formula. Instruction cycle divided by f oscillator. So I know instruction cycle on f oscillator. Instruction cycle equal to 4 f oscillator. Time calculation for the 20 MHz crystal. The instruction execution time clock frequency equal to 20 MHz. F oscillator equal to 20 MHz. Instruction cycle equal to 4 fetch, decode, execute and store. First clock pulse is coming, data is fetch. Second clock pulse, decode. Third clock pulse, execute. Fourth clock pulse is store. Okay. So time equal to 4 divided by 20 into 10 power 6. 10 power 6 mean 10 power 6 mean it is megahertz. So after 20 you can add for 6 zeros. Okay. 20 mean 1, 2, 3, 4, 5, 6. 6 zeros you can add. So 4 divided by 20 lakhs. So this answer is 0.2 into 10 power minus 6. So time equal to 0.2 microseconds. It is converted to round value. So into 1000. So microsecond to nanosecond conversion, multiply 1000. Okay. Time equal to 0.2 into 1000. Time equal to 200 nanosecond. So now 20 MHz crystal oscillator you can use 0.2 microseconds. 4 instruction is completed. So 200 nanoseconds. The PIC executes approximately 5 million instructions every second. Suppose you are controlling a robotic arm in industrial production line. The controller must respond almost instantly to sensors inputs. Using a 20 MHz crystal allows faster processing and quick responses. 4 MHz crystal time calculation. F oscillator equal to 4 MHz. Same formula. Time equal to 1 by f equal to instruction cycle by f oscillator. F oscillator equal to 4 MHz. Instruction cycle equal to 4 fetch, decode and execute and store. Time equal to 4 divided by 4 into 10 power 6. 10 power 6 mean it is megahertz. So 4 lakhs. It is converted to 4 lakhs. Time equal to 1 into 10 power minus 6. 4 into 4, 1. Okay. 4 divided 4. It is answer is 1. 1 into 10 power minus 6. It is converted to microsecond. Okay, it is now is megahertz. It is converted to time, mean it is microsecond. Okay, time equal to 1 microsecond converted to round value, microsecond to nanosecond conversion, multiply 1000. Time equal to 1 into 1000, time equal to 1000 nanoseconds. So compared with a 20 MHz crystal, the controller is slower because each instruction takes longer to execute. Yeah, digital thermometer. I have another one example. A one example. A digital thermometer only reads the temperature every few seconds. It does not require extremely high processing speed. A 4 MHz crystal is sufficient and consumes less power. Okay, default delay library, LED on program, LED blink on library or on functions program as defined underscore crystal underscore FREQ 4 MHz. You can use for 20 MHz, mean you can mention for here 20 MHz, otherwise your LED blink time calculation is differ. So I hope you now clearly understand the concepts of PIC16F877. I hope you now clearly understand the concepts of PIC16F877A time calculation. If this explanation helped you understand the concept, please subscribe to our channel and press the bell icon so you never miss our upcoming videos. Thank you for watching these videos. If you have any questions, leave them in the comment sections. Need help with final year projects, mini projects or IEEE projects, contact on WhatsApp. Don't forget to subscribe and press the bell icon. See you. Okay guys, thank you.